In this video for section 4.2, we're going to start by discussing conditional probability. Conditional probability is the probability that an event will occur given that some other event has already happened. So let's look at example 410. We have a table that shows the results of a study on what percent of their retirement funds that people had invested in the stock market. What is the probability that someone 65 or older has 50% or more of retirement funds invested in the stock market? So when I look at my table, I have age of the investor and I have percent of retirement investments in the stock market. Now the question is, what is the probability that someone 65 or older has 50% or more invested in the stock market? So I know that the person is 65 or older. So when I look at the table, what I'm going to find is the percent who are 65 or older, or the number who are 65 or older, that invested 50% or more, which was 65, and I'm going to divide that by the total number of people who were surveyed that were 65 or older, not the total number of people in the survey. So the way that we write this, and the book shows using a formula for this. I don't want you to worry too much about the formula or the notation here, but I would write probability that they have greater than 50% in the stock market. And then we use this vertical line which says given that. We translate that as given that the person is 65 years old or older. So that probability is 65 divided by 1065. And if I write that as a decimal, it would be 0.061. So the key here is really understanding when you're reading the questions what you're dividing by what your whole is. So if they give you some information, like here I know that the person is 65 or older, then that can tell you to limit your total to either the total in one row or it could be the total in one column, but that you're not dividing by the total number of people in the survey. I'm just looking for the number of people who had 50% or more out of the total number of people who are 65 or older. So in the previous video, we talked about OR problems if we are asked to find the probability of one event or another. Here we're going to look at the rule for probability of one event and another event happening. And if it's an AND problem, we use what's called the multiplication rule, and we multiply the probabilities. Now this only works if they are independent events, but a lot of times we can assume that events are independent or know that they're independent, especially if we're working with things like rolling dice, drawing cards, flipping coins. With those kinds of situations, what happens on our next roll or our next draw is not affected by what happened on the previous roll or the previous draw. So let's look at example 412. An accounting firm has found that 12% of individual returns are audited. Today they signed 2 new individual tax clients. What is the probability that at least one of these returns will be audited? So we can assume that these are independent because whether one person gets audited doesn't really affect whether the next person will get audited. So what I need to do here is find first the probability that both are audited. And we do that by multiplying. So the probability of one person being audited is 12%, and the probability of the second person being audited, also 12%. So it would be 0.12 times 0.12, which is 0.0144. Now, the question here is what is the probability that at least one of the returns is audited? So it could be that the first return is audited and the second is not. So the probability that the first return is audited is 0.12. Now the probability that a return is not audited, using the complement rule, would be 1 minus 0.12. Either you're audited or you're not. There's no other possible outcome. And so that's 0.88. So 0.12 times 0.88, which equals 0.1056. And then the third possibility here is that the first is not audited and the second return is audited. And so probability that the first return is not audited is 0.88. Probability that the second return is audited is 0.12. And that's obviously going to be the same as this one up here, commutative property. So the answer is 0.1056 again. And then what I need to do is add these three possibilities together. So 0.0144 plus 0.1056 plus 0.1056. And if I do that, I get 0.2256. Now, another way that I could have done this problem is find the probability that neither return would be audited. That would be 0.88 times 0.88, and then subtract that from 1, because the opposite of neither return being audited is that at least one is audited. So that's another way you could do the problem.